right, today we're going to talk about the first derivative test. The first derivative test is going to help us in a couple of ways. One, it's going to help us graph more complicated functions. Functions that if we needed to construct a table of values for and plot the points by hand, it could be tedious and time consuming. And the first derivative test is going to make that extremely easy for us. And while we're doing that, it's also going to help us find the relative extrema, the minimums and maximums of our graph. So a graph like this, that could be really difficult to graph by hand because we don't know the shape of the graph based on the function, will become really easy to graph when we're done talking about the first derivative test. All right, recall that f prime of x represents the slope of the lines that are tangent to the function at a given point. It is in fact the rate of change at that point. So if f prime of x is greater than 0, f prime of x greater than 0 means the slope tangent line at x is increasing, like the picture here. We have our tangent line with a positive slope. And if you look at the graph underneath, it is increasing. It's an increasing graph at that point. F prime of x less than 0 means the slope tangent line at x is decreasing. And so, like this picture here, we have a negative slope. And if you look at the graph underneath, it is in fact decreasing. It's on a decline. And f prime of x equals 0 means that there is no rate of change. It's constant. And we call those a critical number, like this one right here, which appears to be a relative maximum. Okay, so I've come up with 5 steps that will hopefully help us use the first derivative test and organize our information in a way that's easy to read and therefore will then be easy to graph. The first step is to take the first derivative. I know that's kind of a given, but sometimes we need to write that stuff down. So we're going to take the first derivative of our function. Then we're going to set that derivative equal to 0, and we're going to factor for the critical numbers. Now I also need to note that the points, some of the critical numbers will be points at which the graph is undefined. For example, if we have a rational function that has a 0 in the denominator, that would be a place where the graph would be undefined. And we need to take those points into consideration as well. However, for our purposes today, as an introduction to this first derivative test, we're only going to focus on a polynomial. So we're just going to look at critical numbers, not undefined numbers. Then you're going to make a table or a number line, sort of like this. We're going to list the critical points and the undefined numbers in order on the line. So we're going to go from least to greatest, and we have our intervals then all set up for us. And then we're going to test a point in each of the intervals of f prime of x, and we're going to list either a positive or a negative for the result of that test for each interval. Okay, so those are our 5 steps. Let's give it a try. So the function that we're going to look at today is 3x to the 4th minus 4x to the 3rd minus 12x squared plus 5. And our first step, if you recall, was to find f prime of x. And so when I took the derivative of the above function, I got 12x to the 3rd minus 12x squared minus 24x. I'm not going to go into how I took the derivative because we've been doing that for a while and I know that you all know how to do it. You can go ahead and check my work, but we're just going to move on and you're going to assume that I'm right. This is the first derivative of the function. Our second step is to take f prime of x and set it equal to 0 and factor to find the critical points. So I go ahead and set it equal to 0. I notice that there's a 12x in each of the 3 terms, and I factored that out. We now have a trinomial that also appears to be very easily factored. And so I rewrote that as 12x times x plus 1 times x minus 2, which leaves our critical numbers to be 0, -1, and 2. These are our critical points. We have no undefined points in this polynomial because we do not have any zeros in the denominator for our purposes today. All right, so keeping in mind our critical points are 0, -1, and 2, step 3 said to make a number line. And step 4, we're going to list the critical and undefined numbers in order at the top of our table. Step 5 says we're going to test a number in each interval. So we really have 4 intervals. We have the interval from -infinity to -1, that's this one right here, from -1 to 0, from 0 to 2, and from 2 to infinity. We're going to start on the left-hand side. So this is our f prime of x in factored form. And we're going to take a number less than -1, like -2. So when I plug -2 into each of these factors, this becomes negative, and -2 and another -2 is negative. So we have a negative times a negative, which is a positive, times a negative, which overall is a negative. So our interval from -infinity to -1 will be, all those numbers will be negative for f prime of x. Then we're going to test a number between -1 and 0. I chose -1/2. -1/2 times 12, that makes that negative. It becomes positive for the x plus 1, and it stays negative at x minus 2. So we have negative times a positive, which is positive. Negative, sorry, times a negative, which is positive. And so overall, our interval from -1 to 0 will be positive for f prime of x. Test a number between 0 and 2. I chose 1. That's positive. That's positive. That's still negative. So a positive times a negative results in overall a negative. And then our last interval is 2 to infinity. I chose the number 3. That's positive. That's positive. That's positive. And so that interval overall is positive. Now, the signs of the derivatives indicate where the graph is increasing or decreasing. Negative means that from that interval, from -infinity to -1, that graph is decreasing. From -1 to 0, the graph will be increasing because it's positive. From 0 to 2, the graph will be decreasing because it's negative. And from 2 to infinity, it will be positive because it's increasing. Now, all of that leads us really, finding the critical points and doing an increasing, decreasing test indicates more information that leads us to the first derivative test. And essentially, it says that if c is a critical number of a function f, and f prime of c changes from positive to negative, from positive up to negative down, then f has a local maximum at c. If f prime changes from negative to positive, so now it's negative to positive, then f has a local minimum at c. And if f prime does not change signs at c, for example, maybe f prime is positive on both sides of c or negative on both sides of c, then the function itself has no local maximum or minimum at that critical point, or that critical number. All right, so if we keep in mind, looking back at what we already have done, our original function and the increasing and decreasing tests, we can see where we might have some relative minimums and maximums. Remember, this was our function, and this was our derivative, and our critical numbers were 0, -1, and 2, and these were the table. This is our graphic organizer, the results of our testing. And when we look right here, around the critical point -1, you can see there's a sign change. It goes from negative to positive. So that sign change from negative to positive indicates that I have a relative minimum at -1. So we're going to take that -1 and we're going to plug it back into our function. Since there's a minimum at -1, we plug that value into f of x to find where it is. So f of -1 is 0. That means that there is a minimum at -1, 0. When you look at our critical number 0, you can see a sign change from positive to negative. That indicates that we have a relative maximum. So again, we're going to take the 0 and we're going to plug it in. That one's really easy. When you plug in the 0, obviously we get 5. So there's a maximum at 0, 5. And at our critical number 2, there's also another sign change from negative to positive. That indicates that there's a relative minimum at 2. So I plug 2 into f of x to find the value of that minimum. F of 2 is negative 27. That means that there's a minimum at 2, negative 27. So that's a lot of information. If we were drawing this graph, we'd plot the points negative 1, 0, 0, 5, 2, negative 27, and we would then draw in our increasing and decreasing. And I went ahead and I verified everything that f prime of x has shown us. It's decreasing where it said it was decreasing. The graph is increasing where the first derivative test said it would. We have relative minimums and relative maximums exactly where they were supposed to be. So that is the first derivative test in a nutshell.